Okay, class, this is March 6, and we're starting to learn about electronegativity. And electronegativity, what it is, and what the examples it is. Electronegativity is a measure of tendency of an atom to attract or bonding pairs of electrons. One of the bonds it has is a covalent bond where electrons are shared evenly between two atoms. Atoms are equally electromagnetic. Both have the same tendency to attract the bonding pairs of electrons. This is an example of a pure covalent bond. That means like they both have the same charge, which causes them to share equally. Also, another one is a polar bond. A polar bond is a covalent bond in which they are separated in charge between one end and the other. In other words, which one end is slightly positive and the other is slightly negative. This means that one of the end of the bonds is more than its share of fair electron density, and so becomes slightly negative. At the same time, one of the A end of the electron becomes slightly positive in the diagram shown. That means negative and positive, and that's an example of a polar covalent bond. Another one is an ionic bond. That means one of the atoms pulls the other electrons so well that towards itself there is a great abundance of electronic charge. If for some reason the bond between the atoms is broken, the atom with a higher electron will actually keep the electrons for itself. This is right here is an example of a ionic bond, and as you can tell, it's completely separated, unlike the other ones where it was still connected. And here's a chart of how it looks, which one has the more charge, which one has less, the positive and the negatives. And then the part on the bottom, it will be explained in the next section of the video. And it was Jorge that did this section, and I think Cole is up next.
Hello everybody, my name is Jorge Reyes, and I'm going to explain to you in the segment on electronegativity scales and comprehension. This is electronegativity, a Pauling scale plotted against atomic numbers. Electronegativity scales and how to read them. The scale used here is a Pauling scale and is determined on the atomic number of the element. The lower the atomic number, the higher the electronegativity is, 4.4 being the highest and 0 being the lowest. And here's different colors to differentiate the elements from 0 to 110 based on the atomic number. More graphs and determining how to read electronegativity in a periodic table. This graph shows some elements and their range of electronegativity. For example, Na, which is sodium, having 1.6 in the electronegativity scale, and chlorine having 3.2. This chart shows from 1 to 4 into the electronegativity scale, and they have Na, which is sodium, Mg magnesium, Al aluminum, Si silicon, P phosphorus, S sulfur, and Cl chlorine, which chlorine is the highest. Continuing from the other slide, a thing to remember is that argon does not form bonds, therefore it has no electronegativity. Reading the periodic table is fairly simple. Starting from fluorine, it increases going to the right and also going to the up. On the opposite, you go to the left and you just go down. It's fairly simple. Distinguishing configurations, otherwise known as distinguishing patterns. The attraction that a bonding pair of electrons for a nucleus depends on the number of protons in a nucleus, the distance from a nucleus, and last but not least, the amount of screening by inner electrons.
Okay, and now for the final part of our presentation. With the periodic table, every element on the periodic table is going to have a different electronegativity depending on where it is on the periodic table and the number of electrons it has. And so as you move from the left to the right side of the periodic table, the farther right you go, the electronegativity increases. And also, it works the same for when you're moving from top to the bottom. As you work your way from the top of the periodic table to the bottom of the periodic table, your electronegativity is going to decrease as you work your way towards the top right-hand corner of finally until you reach fluorine, which has the highest electronegativity of 4.0. And also, as you notice that it doesn't have any of the noble gases, this is because the noble gases don't have any valence electrons. So, as we learned before, electronegativity is the measure of the attraction of an atom for the electrons in a chemical bond. So as the noble gases already have a full outer level, they don't need to bond with any other elements. So how do you calculate what kind of bonds these elements have? When you're calculating this, you need to calculate the electronegativity difference. The way you do this is you have to first find your compound element. It can be any two elements that can create that final outer layer. So once you find these, you look at the periodic table and find what its electronegativity is. Whichever has the smaller electronegativity of the two, you subtract that from the larger one. Once you find this number, this is the number that you'll use on the chart here to your left, the bluish one. And as you work your way up towards the higher 3.3, so as you can see in the first picture, if you have a much bigger element, like let's say fluorine, like we talked about earlier, and you have a smaller one like lithium or something like that, it's going to be a larger electronegativity difference. And this bond is going to be an ionic bond because all the negative energy is going to go to the fluorine, and all the positive is going to go closer to the lithium. So when you subtract these two, if your total is in between 0.0 to 0.3, it's going to be a nonpolar covalent bond. If your total is anywhere from 0.3 to 7.1, it's going to be a polar covalent bond. And anywhere above 1.7 is going to 3.3 is going to be an ionic bond, which, like we talked about, one atom is going to be much greater or bigger or larger in electronegativity than the other. But when it's a covalent bond, the atoms are usually going to be pretty close in size. So I hope this video clears up any questions you had on electronegativity. And this is Cole signing off for our program.
Enjoy this last minute of dancing by Jorge and Cole.
Keep killing my vibe. Keep killing my vibe. Are you recording? Yeah. Hey. Oh. Are you saying you are one time.
There's no music. It's so weird without any music.
I don't like that. I don't like that.
Okay.